Assalamualaikum. My name is Muhammad Rizman, and today I'm gonna present to you my research paper titled Analysis on Parameter Effect for Solar Radiation Prediction Modeling using NNARS. My presentation will be start with abstract, followed by introduction, literature review, methodology, results and discussion, and lastly conclusion. Sun had been acknowledged as an unlimited power source which provides natural, clean and surface energy towards the earth. It has an ability to regenerate, thus known as a renewable energy. To fully utilize this potential, several studies had been conducted in order to obtain a maximum solar energy potential that could be turned into an electrical power. The solar energy potential study involved several parameters. For the study, analysis on the input parameter will be conducted by using prediction modeling developed using neural network autoregressive model with exogenous input. Evolutionary neural network had been developed to further enhance the prediction results based on prediction type and their parameters. Neural network autoregressive model with exogenous input is widely applied in dynamic nonlinear time series prediction model development, including solar radiation prediction. Solar radiation prediction model developed previously had been using multiple input parameters. In this paper, some common input parameters had been selected and analyzed their effect based on final prediction output. Solar radiation measured using its intensity, and it is referred as solar irradiance value. Solar irradiance captures by photovoltaic panel to be converted into an electrical energy. Solar irradiance properties as shown in the figure is divided into direct, diffuse and ground reflected. Based from this, we know that solar radiation have influenced by various factors, as this factor is referred as input parameter for the prediction model development. This parameter can be further classified into a stationary parameter and also unprecedented parameter. Stationary parameter is referred to the geographical parameter based on specific location, while unprecedented parameter refer to the meteorological parameter such as seasons and weather condition. This study is aligned with previous research reports. It is carried out to obtain and analyze the final results based on input parameters selected. This is done to develop a further analysis on the effect of the input parameter towards the solar radiation prediction values. This will also help in enhance the result from prediction model development by using NNARS. Based from previous study, it is shown that sunshine duration is the most significant parameter that have been widely used for input parameter for solar radiation prediction model development, compared with other parameters such as temperature profile, cloud coverage, wind speed, relative humidity, clearness index, and weather effect. NNARS is the current dynamic network with feedback connection and several layers of the network. It is based on ARS model which applies in time series modeling for a time step function. There are two architectures of the NNARS, which is parallel and series parallel. Parallel is known as a closed loop architecture, while series parallel is known as open loop architecture. In parallel architecture, the output from the network is feedback to the feed-forward network as an input. The prediction is performed with the combination of present and previous input and the feedback from the past predicted values in form of time series. While in series parallel, the true output created during training without the need of feedback for estimation. The prediction is performed with the combination of present and previous input and additional trained past output value in form of time series. The methodology of this study starts with the input normalization by using sigmoid transfer function. The process continues with the training and generalization process where 80% of the input data will be used. Next, it proceeds to the testing process where 20% of the remaining input data will be used. And lastly, the performance evaluation is carried out using predicted and actual values. To preserve time dependencies, cross-validation applied where training of the time series data is partitioned into 10 folds. Each folds are the combination of training set and a randomly sampled test sequence. The performance of combination of different hyperparameter value is evaluated using one step ahead calculation based on MSE values. The Levenberg-Marquardt function used for weights update for each neuron to avoid overlooping problem. The input parameter selection is divided into three models, which namely as NN1 model, NN2 model and NN3 model. For NN1 model, solar irradiance parameter and temperature will be used, while for NN2 model, we use solar irradiance parameter, temperature value, solar azimuth angle and also solar zenith angle. And lastly, for NN3 model, we use the combination of solar irradiance parameter, temperature value, solar azimuth angle, solar zenith angle and sunshine duration. The figure shows the results obtained from NN1, NN2 and NN3 model. Based from the results, it is shown that NN3 model had given the best prediction result compared with NN1 and NN2 model. This is also supported by the findings made by previous researchers that sunshine duration is the main and dominant parameter for the solar radiation values. As for the conclusions, this paper successfully execute the solar radiation prediction modeling based on 1 week ahead prediction by using NNRS on MATLAB R2019A software. Based from the results, it is shown that the selection of input parameter had given an impact toward the prediction results. As for solar radiation prediction, there had been numerous input parameters that had been considered based on the previous study. Since it is highly dynamic data, the analysis to find the most dominant parameter must be established. Based on the results, it is shown that sunshine duration is the dominant input parameter for the solar radiation prediction. As for future recommendation, it is suggested that analysis on weather effect on solar radiation value conducted based on specific climatic data. With that, thank you.